Okay, so we're going to do titration curves as an experiment, and the first part of the experiment is you're going to be assigned a compound. For this demonstration, the compound I'm going to use is what's known as tris base. Okay, so I have a little jar here of tris base, and it says to figure out how much you will need to weigh out to make up a 250 milliliter solution. So I have a 250 milliliter volumetric flask, got a weigh boat here, and you have to make it a 0.1 molar solution, 250 milliliters. Okay, so you'd look up the compound, figure out approximately how much you'd have to weigh out. Then we're going to go weigh it out, and we are going to add it to the flask, make a solution. Okay, something you've already done before. All right, so I'm going to go ahead and do that. Then we're going to take a sample of that solution, pipette it into this beaker that has a magnetic stir plate underneath it and a magnetic stir bar in there, and it's set up over top of a burette because we're going to do a titration. And since I am using tris base, my what's going to go in the burette is hydrochloric acid. Okay, that's standardized, so we'll know the concentration. And we're going to do the titration, except this time we're not going to use a indicator, right? It's not going to change color. How are we going to know what's happening in the acid-base reaction that's going to go on in the beaker? Well, we're going to use a pH meter. Okay, so this is a pH meter here, and then this is the pH probe that we're going to hook up, and you have to calibrate it using different buffers. Okay, and I will show you that a little bit later on. So we're going to show a little bit of the solution being made and the burette set up, and we're going to show how to calibrate a pH meter. And we'll take a few pieces of data, but mainly you're going to get a set of data from your instructor. So you already know how to titrate, you already know how to make up a solution. The only new technique in this experiment is how to use a pH meter. Of course, there's a lot of calculations, which is the second week of this experiment. Okay, so I've made the tris base solution. I weighed out a quantity and transferred it to the volumetric flask. I filled it up to the mark. I inverted it 15 to 20 times. I went and got a bottle to store it in for next week. So I got that done. And over here on the burette, I checked it to make sure it was clean with some deionized water, then rinsed it with a little bit of HCl, discarded that to get rid of all the water, and then filled it with HCl. So it's all ready to go. Okay, I haven't put the sample in yet. But then the last thing we want to do is how we're going to monitor the titration is using a pH meter. Okay, so I've got the pH meter here. It's battery operated. I've hooked in the pH probe here, connector. Okay, the pH probe, right, is sitting in a storage solution. Okay, and I'm going to show you that here in a minute. Also, I put in a temperature probe. Now, usually the temperature probe, it's not critical. As you can see on the instrument, there is a temperature gauge, and you can see the little arrow on the handle there, and it's pointing between 20 and 30, 25 and 30 degrees. Okay, see, which is what the temperature reads. You slip the indicator over here to the temperature. The main thing it was with the temperature is check that this here is pointing roughly in the right direction. I mean, there's no way you're going to be able to tell if it's 28 or 27 or 26, but as long as somebody hasn't accidentally moved it to like 60 degrees or something like that, or down to 0, you should be fine, because sometimes people hit the wrong button when they're doing this. All right, so we've got the pH probe, and I'm going to show you how to calibrate this. In order to do that, you need buffers. Okay, buffers at different pH values, standards basically. Okay, every time you always need a pH 7 standard. There's a color coded. 7 is the yellow 7 buffer solution, okay, or faint yellow anyway. And there's a lot of times, there's a couple of these bottles in the case here with the pH meter, because the probe is stored separately. You need this pH 7 buffer. You also need a second buffer, okay? Now, we have a couple of choices. We have a pH 4 buffer, which is red, and we have a pH 10 buffer, which is blue. So this type of pH meter has a 2-point calibration. You calibrate, use the calibration button for the pH 7 buffer and the slope button for your other buffer. So which one do we use? Well, we use the pH 4 if we're using an acid, right, because we'll be down at lower pH. We use the pH 10 buffer and calibrate the second point above pH 7 if we're dealing with bases. So since we have tris base, we're going to use the pH 10 buffer. You also need a squirt bottle with some water in it and a box of Kim wipes in order to get the probe calibrated. Okay, so calibrating a pH meter. Okay, first you always double check that the temperature is at the appropriate spot. You can use the temperature probe attached if you wish, but usually as long as you're pretty close, it's pretty good because it's not that precise. Okay, then I have my pH probe that I've attached. Make sure it's a good connection. All right. Now the pH probe is kept in a storage solution, so I have to get it out of this little storage solution vial before I can do anything else. And so I unscrew the vial. Okay, maybe there we go, so we can see it hopefully. So I'm unscrewing the vial here, or the little container. Okay, I'm going to set that down, and now I'm going to take off the top of it here. Okay, I find that works better than trying to pull that out of there just first, because this way you don't have a whole bunch of solution in there. Okay, and then I'm going to take this little thing. It's very easy to knock over, and even if I put the cap on obviously has a hole in it because that's where the pH meter goes through. So I usually set it up on top so it's out of the way before we get started. All right, so here's the pH probe. The actual probe is this little ball down here at the end of this. Okay, this other piece around here is a plastic guard because that's very, very thin and fragile glass, and we don't want that to be broken. Okay, so we leave the guard on here at all times just so we don't break the pH probe. Eventually they do break with no fault of a student, but we try to protect them as much as possible. Okay, so before we're going to calibrate it, we have to rinse off the solution that it was sitting in. Okay, so we bring it over to the sink, and we rinse it off with a little bit of deionized water. Okay, now, then what we're going to do is we don't want to put that water in with all our buffers. We keep that way you would keep watering it down. We're going to dry it. Now we're not going to rub the fragile glass. What we're going to do is we're just going to kind of dab it and get the water off the guard more than anything else. Okay? Now, the first buffer we stick it in order to calibrate is the pH 7 buffer, okay, which is the yellow. Now I find that these little places here in the case for the pH meter holds these, because if you don't, they tend to tip over because this is kind of top heavy. So I put this in here. Now you've got to move this around a little bit. Okay, make sure that you get the solution around that probe, and you can see that it's reading roughly 7, but not exact. Okay, so what I need to do is I use the calibration button, and it has grooves in it, so you kind of push down on it from the top and turn with your thumb or your finger, and what you want to do is you want to get that so that it reads 7. Okay, you want to make sure that, right? Right, now theoretically you would, you put a little stir bar in there, but it's fine if you just move it around a little bit, make sure. Okay? So we've got a pH 7, that's the 1 point of the calibration. For the second point of the calibration, I repeat the process, except this time I use one of my other buffers, either the pH 4 buffer if I'm going to be doing acids, or pH 10 buffer if I'm going to be doing bases. In this case, I'm going to use the pH 10 buffer. All right, so I'm going to put that in this other spot. Now, I don't just pull this out of here and stick it directly into the 10, because then I'm going to take some of the 7 buffer into the 10. So again, take it out of the solution. There's a little bit of the 7 buffer in there, and I need to rinse that out. So you bring it back over the sink, you rinse off the probe. Again, get off the majority of the water here by dabbing it with a Kim White. Okay, and then I stick it into the pH 10 buffer. Okay, and again, it's not reading 10, but it's close. This time I don't use the calibration button, I use the slope, which you can see this arrow points that way, because this is the second point of the calibration, right? So you're making essentially a straight line. Okay, so I'm going to adjust this until it reads 10. Get it to exactly 10. It can be a little touchy on that last digit. Okay, that's pretty close. Pretty close to 10. Maybe a little bit. Wrong way. Whoop. Yeah. Right, but that's the 2 points, right? There's always a little bit of uncertainty in that last digit. Okay, so now you've got the 2 points, you say, okay, I'm done. Well, usually just to double check, because now I've changed both points, what I'm going to do is rinse it, put it back in the pH 7 buffer, make sure it goes back to pH 7. Okay, so again, I rinse off the pH 10 buffer. Again, I'm going to dab off the water here. The majority of the water off. And then I'm going to stick it back in the pH 7 buffer, and it should go back to pH 7. Okay, so it's calibrated. Now, just to check to see how good the calibration is, and this you wouldn't have to do, is I'm going to go ahead and rinse it and put it in the pH 4 buffer, and let's see how good it goes that way, just as a test. Okay, so again, rinse this off. Dab it dry. Now I'm going to put it into the pH 4 buffer, just to see where that would be. You're saying, wait a second, shouldn't that read pH 4? Yes, it should. But remember, where we calibrated at 7 and 10, we're way down at pH 4. Right? So it's not nearly as accurate away from the second calibration point. So if I were doing acids, I would use the slope button to put this at 4, and then I'd be much more accurate at low pH. But if I got really high pH, it's not going to be quite as accurate. I mean, it's still pretty close, but it's not going to be as accurate. So that's why you want to choose the second buffer depending on what your application is. Okay? Okay, so I've now pipetted my sample into here, and I've got the pH meter calibrated, and it's put in a spot where hopefully you can see that. Now I'm going to bring the pH meter in. Now the tricky thing with this setup is you got to make sure that you get your burette so it drops into there. You also have your stir bar going, plus you got the pH meter, and you don't want the stir bar hitting the pH meter. You got to get it all into that spot. So I'm going to first rinse off the pH meter from the pH 7 buffer. pH probe, yeah, the pH probe, sorry. Yeah, the meter's there. This is the pH probe. All right, and I'm going to put it in this clamp that I've arranged so that it's over here on the side, and hopefully you can see that it's covering the bulb at the bottom is covered with the liquid, okay? And so we need to take the initial pH there, and so hopefully now you can sort of see that. Okay. Okay, sorry, there's kind of a glare on from the lights. There we go. That's a little better. All right, so it's a pH of 9.83. I also have to have, well, let me turn the stir on, make sure it doesn't hit the stir bar. Okay, it looks fine. 9.83, 9.84. Right, I also have to read the initial value off the burette, which is 0.87. All right, so the first, it says now we're not going to an end point, so we're just adding different amounts and reading what the pH is. I'm going to lower this down just a little bit, make sure that the tip is down in there. And it says the first one is to add about 0.5 milliliter, so I'm going to go to roughly about 1.3 on the 1.4 on the burette. Okay. And so you can read off the pH, and I'm going to read off the value off the burette as, let's see, 1.3, 1.32. Okay, and I'm going to do another half mil here. We'll just do another half. So we need to go about there. And the new burette reading is 1.80 milliliters. Right, so now when you're actually going to plot this, you're not going to plot burette reading with pH of 8.99. You're going to plot how much total volume you have added. So that initial volume of 0.87, you have to subtract it off of all the other readings to get the volume that you've added. All right, so now I'm going to go, as you can see that the pH isn't changing by that much. I'm going to start going by 1 mil until it, for a couple of readings here. All right, it doesn't have to be exactly 1 milliliter. It's 2.79, okay? And the pH of 8.68. One more. And we've got a volume of 3.83 and a pH of 8.48. Okay, so I have Dr. Veldkamp recording for me. We're not going to bore you by taking all these points and sitting here and having a long video, so we're going to pause this and then we're going to come back in to show you where the pH starts really rising really quickly with a very small amount, or pH dropping very quickly with just a very small amount of HCl added. Okay, so we have been adding we're at about 24 before 25 milliliters on the burette reading, and you can see the pH has only dropped to 6.65. But the last one, it went down quite a little bit with the milliliter, so now we're going to start slowing down here. Okay, so I'm not going to add as much, and we're going to take a few readings here so you get an idea of what's happening. Maybe a little more. All right, so now we're at 25.46 and 6.42. Uh, 25.81, 6.24. So I added just a few drops, and it's going down by 0.2 each time. So now we're at 26.01, 6.06, 26.32, 5.74. So what we're doing here is we're getting close to the end point because I'm adding a very small amount of titrant, but I'm getting a decent pH change. So I'm going down to a small, I'm adding very small amounts, so I get lots of data points here. Kind of drop hanging. I'm going to try to get just the one more drop. There we go. 26.4, and 5.25. Okay, there it went. We got up to about 2 drops or 3 drops. This is now 26.59. And we dropped all the way to 3.48. All right, so we're going to try adding one more drop, see if we can get another data point close to that. 26 point, let's see, it was 26, what was it before, 26.58, so yeah, 26.6, that's what I was thinking that line was, 26.62, and 3.20, that was one drop, so more drop. We're at 26.6, 9, 3.04. .80, 2.84. so you can see that it have to add a little bit more now because I'm past the end point. 27.000. 2.60. Twenty-seven point 28, 2.37. Okay, so I had to add quite a bit there, and it's still not going much anymore, so. Okay, 27 point, 68, 27.68, 2.21. All right, so we're past the end point now. So it says to take a few more readings, 1 mil each, just to get a few more data points here. All right, 28 point. Let's see, that's 6.3. 1.98. So we're going to stop the recording because you're going to get data from the instructor, but we're going to continue and read a few more points before we're done. Okay, now that I'm done with the titration, I wanted to save all the rest of my solution here. So I've transferred it out of my volumetric flask because you don't store things in volumetric flasks, especially acids and bases. So I put it in this jar, and now I have to label it. And so good laboratory practice is when you label it with a few different things. The name of the compound, obviously, the name, your name, so they know who made it, the date, and in this case, we're going to put in how it was made, meaning how much I weighed out in a certain amount of water. If we knew the calculated the concentration, you would put the concentration on that. So that's how we're going to do this solution. All right, so I'm going to label it, and then I'm going to show it to you. Okay, so I labeled it. You can see tris base. That's how much I weighed out in 250 milliliters. And then I put my name and the date. Okay, now I didn't space that out very well, but it is labeled with all the pertinent information, so somebody needed to know anything about this, the pertinent information is there, or they can contact me, and they know how old it is.